What's up everyone? In this video, we're going to find out the largest square number less than 100 in base n. And again, if you don't know what it means by the subscript n here, you can go back and check out my previous video. I have a full explanation about the subscript. Alright, so let's start with some examples. The expression 100 in base 10, where we usually don't write it, just really means 100. 100. And since we're in base 10, we know that the largest square number that is strictly less than 100 is 81. All right, so let's look at another example. Let's say this time we're going to do it in base 4, for instance. Okay, so what does this really equal to? Again, this notation means we have one copy of 4 to the second power plus 0 copy of 4 to the first power plus 0 copy of 4 to the 0th power, which is 1, which gives us 1 times 16, which is 16 here. So the largest square number less than 16 is 9, which is right in this form. And again, we need to convert it back into the base 4, which is written as this. So perhaps we can get one more example. Let's say we're doing the expression 100 in the base 16. So again, this expression means we have one copy of 16 square plus 0 copy of 16 to the first power plus 0 copy of 16 to the 0th power, which gives us 256. And we know that the largest square number that is strictly less than 256 is 225, which is 15 square. And how are we going to write it in the base that we have? We can just do the long division aside and we'll be able to get the answer. And we can just do the long division twice at most, because we know that the number that we have should have at most 2 digits. So let's see. We have 14 remainder 1, meaning the last digit is 1. And 14 is written as letter E in base 16. So we have the following expression, E1. All right. What do we notice in these examples? Well, if we pay attention carefully, we see that for all the largest square numbers that we found, the last digit is always equal to 1. Where the second digit that we have is actually 2 less than the base number. Example, if our base is 10, then the number that we have will be 2 less than 10, which is 8. If we have base 4, the number that we get will be 4 minus 2, which is 2. Similarly, if we have base 16, the digits that we get will be 16 minus 2, which is 14, and we will denote it again with the letter E. Alright, so from the examples that we got, we can get the following. We will say that the largest square number less than 100 in base n takes the following form. n minus 2, comma 1, where this comma is just a separator, but this time it's not separating the integer part and the decimal part. Instead, we are now just trying to separate each digit. So this is perhaps similar to when you use a calculator. Sometimes when you see a number with 5 or 6 digits, let's say 10 million, 10,000, sometimes we will see a comma right there. This is what the comma really means. Nice. Okay, and last board, we claim that the largest square number less than 100 in base n takes the form n minus 2 comma 1. So here is our proof. First, we're going to rewrite this as an algebraic expression. N minus 2 comma 1 means we have n minus 2 copies of n to the first power plus 1 copy of n to the 0th power. And now we are going to distribute the n, so we get n squared minus 2n plus 1 times n to the 0th power, which is 1. So we get plus 1. And notice that this is actually a perfect square. And we can factor out into the form n minus 1 quantity squared. And now we just need to verify that this is in fact the largest square number that we can take. It's less than 100. All right, so let's jump in. All right, so let's see how we can show it. Well, we know that as a fact, we can list out the square numbers. Well, first of all, we know that if we're going to list out the square numbers in an increasing order, starting from 1 squared, we will get the following. All the way up to n minus 1 squared and n squared. But again, since we're writing it in base n, the number n will have the expression 10. And again, this is not the same as 10. It is just the notation that we use in base n. Okay? Where we know that 10 squared is just the same as 100, similar to how we multiply 10 by 10. We just got 2 zeros after the 1. But notice that this actually hits the bound that we have. And also, now we actually get 3 digits here. That means all the numbers before in the before 100 in the list will be 2 digits or less. And since we're writing it in an increasing order, it means that the term right before 100 will in fact be our largest square number. And again, n minus 1 quantity square is expressed as n minus 2 comma 1. And therefore, n minus 2 comma 1 will be the largest square number that is less than 100 in base n. Right, that's it. Pretty cool, huh? So I think this is actually an interesting, you can say it's a fact, but we can also say that we proved it somehow. When we are trying to consider just numbers itself, we can actually use algebras to play around and see what we can observe. And yeah, that's it. So if you enjoyed this video, please don't forget to like. And if you want to watch more of my videos, you can subscribe or go to my channel and check out my other videos. And that's it for today's, and that's it. I'll see you next time.